This week, I want to talk about holes and the different ways of creating them using the hole command. Um, we saw a week or two ago, over the last couple of weeks, you can make holes by doing a sketch and then extrude a cut, which is fine to do that, but the hole tool right here is a much better way to do that because when you go to creating drawings, there is a hole and threads uh, dimensioning tool that pulls the data from the part. And if you use the hole command to create it, it makes dimensioning that hole much easier. So let's look at the hole command here, and we'll go through these things before we actually start placing some holes. Um, Positions. This is where you'll click to it kind of an automatic thing. It starts placing the holes. If you've got points already created in a sketch, this right here turned on will automatically um, pick those points for you. So you've got four different hole types here. The first is a simple hole. It can go all the way through, or it's just a hole with a set diameter. Then you've got a clearance hole, which you tell it the size of your fastener that you're going to be using, and then it will oversize the hole by a standard amount for that fastener to go through the part. Okay. Um, the next is a threaded hole, in which you would pick the type of thread that you have. Most of these are going to be an ANSI unified or an ANSI metric that you're going to pick. Occasionally, there's going to be some pipe threads that will be in some of our projects, okay? And then next is a tapered hole, and these are pipe threads for pipe, national pipe thread for PVC pipe or just straight national pipe threads. Okay, and then for each of these types, well, almost all of them, I mean, the tapered hole can't have a counter bore. But for the rest of them, it can either be no type of seat or a counter bore, okay, in which you would put in the diameter and the depth of the counter bore. You can have a spot face. Is it still called spot face? Yeah. So you got a spot face, which is like a counter bore, but it's very shallow. And then you've got a countersink, in which you'd apply the diameter and the angle of that. Now, in all of these, you can go a distance, like if you're doing a blind hole, you can go a set distance, and then the 135 is normal for a drilled hole, okay? So you've got your hole diameter and then your depth of your hole. That's most of your drilled holes are going to be with an angled bottom. If you have a specific instance of a part that has a flat bottom hole, which is, it's not rare, but it's unusual because it costs more money to make a flat bottom hole than it costs to do just a drilled hole like this, okay? These other things here are new. I'm not sure exactly what those are. Angle V, flat W. Okay, so this is dealing with finishes and things like that. So we can look at those in a more advanced setting, okay? Don't need any of those. All right, so the first thing you do is you pick your hole type and your seat type, and then you've got terminations. This can be a distance with a depth. You've got through all, and then you've got to a surface. Okay, and so that it can work out either way with those. Most of the time, you're going to be dealing with either a distance or through all. And if it goes through all, meaning it goes all the way through your part. Select that because then there's no depth assigned to it. It just goes all the way through. Okay, there's as far as placing the holes, you always pick the surface of your part that your hole is going to start on to begin with. And then if it's a what we would call a linear placement, meaning a distance from two edges, then you click those edges and dimension them. If it's a concentric, then you would pick the arc that it's concentric with, or the circle. So we'll start with a linear placement. So I'll click on this surface, and well, let's change the diameter of that to something recognizable. We'll say 0.2 inches. Now I click on an edge, and I'll say that's a 1 inch, and I'll hit tab. And then I'll pick on this edge, and I'm going to say that's 1 inch, and hit tab or enter. And then it places the hole. Okay. And so we'll do it again. And I'm going to go with this surface, and I'm going to go with concentric. Oh, it didn't pick it. Oh, I don't know. Okay. And when I pick that arc, it automatically aligns it up concentrically. Okay. Now, if let's say for this one, I'm going to make this one bigger. I'm going to say 0.5. And I'm only going to go a certain depth. I'm going to go 0.5 deep and tell it OK. Now let's change our view over so that we can see the hidden lines shaded with hidden edges. Let's try that one. And flip this up. And if you're following along with me, you can see the outline of that drilled hole. Let me go ahead and make that wireframe. So now you can see the shape of the hole in there. Okay, so let's change that back. To edit, maybe you place the hole and then something's wrong with it, so you can always come back in here and go edit feature. And let's say this one should have a counter bore, or let's make it threaded. You're going to run into some of these sometimes. And the type of thread is, if it's an inch imperial project, it'll be ANSI unified. If it's a metric drawing, it'll be an ANSI metric in profile. The others are metric and Japanese and German and British and stuff like that. So they just come included. So we'll stick with that. And then the size of the fastener, the designation, most of these will be in the in the drawing that you're going to be creating. So you just pick what it shows in the drawing. Direction, most of them are going to be right-hand threads. Okay, and let's just go ahead and make this one through all. Well, no, let's back up. So with this, we've got a depth of the hole, and then we've got a thread depth. One of the things about threads is when you have a blind hole like this, we'll say the hole is 0.75 deep, they can't create threads all the way to the bottom of the hole. There's always a set distance that will be unthreaded, or the threads will not be fully formed. And we'll cover that once you get into the 1111 class. But in a case like this, you would set your thread depth and your hole depth. Okay. All right. And so let's go back in to edit that one again and look at the counter bores. Counterbores and spot faces all work the same, and the countersink. Just countersink, you have an angle instead of a depth. So we'll look at the counterbore, and you can see here you've still got your hole depth, your thread depth, and now you've got the depth of the counterbore and the diameter of the counterbore. And so you would set all of those types of things. Okay. And that really covers a lot of the stuff on this. Another way is with the points, and I'll show you. And we'll go points, and you can, especially if you've got a whole series of holes that are the same size and they're in a pattern, you can place a series of points and then dimension those points. I don't know why I was thinking I could dimension all the way through like that in a chain. Uh, and then I'll dimension from the edge to the top. Let's make that 0.3. Okay, and now then, I could go back and apply dimensions to all of these, because as it is now, they're not aligned. So I could come in here and apply a horizontal constraint to this hole, to that, and then that to that. And that gets those all aligned horizontally, and then we've dimensioned them across there. I could do the same thing down here. So let's dimension from this edge to this point. Come on, dimension. And I'm going to pull out here. And when it goes to edit, I'm going to click on this dimension, and that will make it equal to that dimension. Okay. And then I can apply my horizontal constraint, still in the dimension command. Okay. And then I could do a vertical constraint from those two, and then those to those. Okay, and so now I've got the thing fully constrained, and that's my sketch. So I can go OK. I can go to my hole command. I pick what kind of hole that I've got. Hex head bolt. I'm going to go with a hex head bolt. ANSI. My bolt size, I'll say 1/4 of an inch for the bolt size. And I'm going to go and say through all. And they go, OK. And so you see that way I've got one command, one hole command, this one here, but it placed all 6 of those holes. Looking at my notes, that that pretty much created everything. Once you've created some things, now another way that we could have done that, let's go back here and edit my sketch and take all of that out and finish that. Okay. One thing I probably haven't mentioned yet, anytime you go back and edit a sketch or edit a feature, you may get an update arrow up here. Okay. So it means you've done something in your model and it needs to, usually it updates automatically, but we'll say it needs to update, and you just click on that if that's highlighted, lightning bolt there, and it would update. Okay, so now if I can mirror these holes that I've already created, and I'm thinking backwards. Okay, the mirror and patterns, in Inventor they call them patterns, in AutoCAD we call them arrays. They work pretty much the same way, but I want to mirror features, and so I go through and I select those holes, and I need a mirror plane or a line that I can mirror these things about, and depending upon how I created my part, I can use one of these planes here. And to show you what I did, so when I started this part, the center of this hole right here is at the origin. It's at the 0, 0 point. In Inventor, it's always good to tie something in your part to the origin. In this case, the center point of this arc, okay, is at the origin, or it could be, be the lower left corner of the part, or something like that. It's good practice to do that because you can use these surface planes in creating your part and dimensioning from. So in this case, I'm going to choose my mirror plane. I'm going to choose the XZ plane, and then go OK. And now I've mirrored those parts. So if I edit these first three up here, it will automatically update these down here too. Okay, so that's how to use holes. A lot of options there, and different ways of doing different things. But that covers how to create holes. If you got questions, send us an email or come by the lab and see us. Okay.